All right, so now that we're familiar with all of the trig graphs, y equals sine x, y equals cosine x, and y equals tan x, let's see what their inverse graphs look like. And just recall that if we have a function f and we want to find the inverse of f, then we have to reflect it over the line y equals x. So what we're going to do is reflect sine, cosine, and tangent over the line y equals x. So let's start with sine. So I'm going to graph sine from negative pi to pi. So this is negative pi over 2, pi over 2, and pi. So we have an amplitude of 1, which is telling me that I have a 1 and a negative 1 on the y-axis. So let's plot the ordered pairs for sine. And we end up with something that looks like this. So here is y equals sine x from negative pi to pi. So what we're going to do, we're going to take all these ordered pairs and we're going to switch x and y. So let's plot ordered pairs for y equals arcsine of x. So let's set up an axis. But now take a look at how our axis is set up over here. Over here, our x values are radian measure, and our y values are integers. Since we're interchanging x and y, that means our old x values that were radians are now y values that are radians. Okay, since we're interchanging x and y, we also have to interchange the way that we're describing these numbers. So the x-axis will be in integers, and the y-axis will be in radians because of us interchanging x and y. So let me just set up my y-axis exactly how I have my x-axis set up. So I'm going to have pi over 2, negative pi over 2, and negative pi for my y values now. And now I'm going to have x values of negative 1 and 1 because those were my y values. So let's go ordered pair by ordered pair and interchange x and y. So we had the ordered pair negative pi 0, so we're going to have 0, negative pi. We had negative pi over 2, negative 1, so we're going to have negative 1, negative pi over 2. 0, 0, 0, 0. Pi over 2, 1, so 1 pi over 2. Again, I'm just interchanging x and y here. And then pi, 0, so 0 pi. So now we have to connect it. And here's our graph. Now, the issue here is that our title was graphs of inverse functions. This, if you take a look at it, does not pass the vertical line test. This is not a function because we're repeating x values here. They were y values, now they're x values. This is not a one-to-one function. So this is not a function at all. Because once we interchange x and y, we have repeating y values. Those repeating y values are now repeating x values. So this problem, we have to go through what's called a restricted domain. So that means we have to restrict the domain of sine and find the inverse to make sure that its inverse is a function. And the way we're going to do that, we're going to take this portion here and cut it off. And we're going to take this portion here and cut it off. Now you can see the graph of inverse is a function. And let's just see, where did we restrict this domain? If you take a look at our y values, we stopped it and cut it off at negative pi over 2, and we stopped it and cut it off at positive pi over 2, which means for sine, we will have to restrict the domain from negative pi over 2 to pi over 2. Okay? So this is what the graph of inverse sine looks like. Now let's graph cosine. I'm going to graph cosine again from negative pi to pi. We'll set up an axis. We're on both sides of the y-axis, so give yourself some room to plot on the left. Let's call this negative pi over 2. Let's call this negative pi, positive pi over 2, and positive pi. The amplitude is 1, so we're going to have a 1 and a negative 1. So let's plot ordered pairs for cosine. We're going to have here, 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 there, and there. Here are our ordered pairs for cosine from negative pi to pi. And again, we're finding the inverse, so we're going to interchange x and y. So let's take a look at the graph. Black here. Of arc cosine, or cosine inverse. Okay, so the graph of the inverse cosine will now interchange x and y. For the old x values that were in radian measure, now they're y values in radian measure. The old y values that were integers are now x values that are also integers. So my x values will range from negative 1 to 1, and my y values will be, let's move this down a little bit. Let's see, pi over 2, pi, negative pi over 2, and negative pi. So let's plot all the pairs now. We had the ordered pair negative pi, negative 1, interchange x and y, becomes negative 1, negative pi. We had the ordered pair negative pi over 2, 0, so now we have the ordered pair 0, negative pi over 2. 0, negative pi over 2. We had the ordered pair 0, 1, so now we're going to have the ordered pair 1, 0, 1, 0. We had the ordered pair pi over 2, 0, so now we're going to have 0, pi over 2. 0, pi over 2. And we had the ordered pair pi, negative 1, so now we're going to have the ordered pair negative 1, pi. Negative 1, pi. So now, if you take a look at what this graph looks like, it's a reflection over the line y equals x to make it look like so. There's our graph. Again, if you go back to the title, inverse trig functions. This is not a function. It does not pass the vertical line test. So now, if we take a look at our restricted domain for sine, our restricted domain was from negative pi over 2 to pi over 2. If we do the same here and restrict it at negative pi over 2, pi over 2, we have like a sideways looking parabola thing. That's not a function either. So we're going to have to restrict it at a different spot. The way we're going to do that, we're going to take this portion of the graph and stop it right there. So this is going to be our graph. So our restricted domain, taking a look at the radian measure, is going to be from 0 to pi. So let's take this portion of the graph and get rid of it. There's our restricted domain. So we're restricting cosine from 0 to pi, reflecting over the line y equals x, making sure that inverse cosine is a function. So our restricted domain for cosine, to ensure that cosine inverse is a function, is from 0 to pi. Okay, one more inverse graph to look like. Let's graph tangent. I'm going to graph tangent from negative pi to pi, just like the other ones. I may not use all of that, but let's see what it looks like from negative pi to pi. Let's set up an axis. negative pi over 2, negative pi, pi over 2, and pi. So the graph of tangent at vertical asymptotes at all the odd multiples of pi over 2. So every over 2, you're going to have an asymptote. So let's put that in there. We have an asymptote here. We have an asymptote here. The graph never crosses there because tangent is sine over cosine, and this is where cosine is 0. So we're going to have 0 in the denominator. So let's plot some order pairs. There's the graph of tangent. And you can see that if we were to graph the inverse tangent, we're going to have a lot going on here. So we're going to restrict the domain from here to here. We're only going to graph one of these little tangent graphs, because the tangent graph is this, repeating over and over. So get the idea of inverse tan, all we need is this thing here to reflect over the line y equals x. So let's graph tangent inverse, or arc tan. Okay, so to do that, let's set up an axis. Our old x-axis was in radian measure, which means our y-axis will also be in radian measure. Okay, so let's restrict our domain from pi over 2 to negative pi over 2. And our x values are from, our y values are 1 and 1, 1 and negative 1. Okay, this is all we have for tangent. So let's interchange x and y. We had negative pi over 4 and negative 1. Negative pi over 4 and negative 1 after you interchange x and y is now negative 1, negative pi over 4. Negative 1, negative pi over 4. That's 45 degrees, half a 90. We had 0, 0. That means we have 0, 0. We have pi over 4, 1. Which becomes 1 pi over 4. So now this is a reflection over the line y equals x, so make sure it looks like that. There is the graph of arc tan. Notice the difference between arc tan, arc sine, and arc cosine. I did not include arrows for arc cosine. I did not include arrows for arc sine. I did include arrows for arc tan. Let's think about why that is. The range of tangent, all reals, goes all the way up, all the way down. Well, since we're talking about y values, talking about a range, those are now x values for its inverse. So if these y values are all reals, then these x values are all reals. That's the only reason I included arrows here. So now the restricted domain tangent, negative pi over 2 to pi over 2. And just remember that pi over 2 had asymptotes there. We're reflecting over the line y equals x. So this also has an asymptote at pi over 2 and negative pi over 2. So these vertical asymptotes became horizontal asymptotes. So just to review the restricted domains, for sine, we're restricting from negative pi over 2 to pi over 2. For cosine, we're restricting from 0 to pi. And for tangent, we're restricting from negative pi over 2 to pi over 2. So the easiest way to remember is that cosine is the one that's different from 0 to pi. You could also take a look at these graphs in your calculator. So if you have your calculator in radian mode, the only time you'll be in radian mode, then we can graph y equals, let's say, second sine of x. So second sine is inverse sine graph. And now you can recognize it from your calculator at least. You can see it passes through the order pair 0, 0, as opposed to cosine, second cosine x. That does not pass through the origin. So that's an easy way to take a look at the differences between arcsine and arccosine. And you could also graph tangent, second tan x graph. And there we go. So it's an easy way to draw a difference. If you're given the graph, then you could easily determine its equation by plugging into your calculator.